Hi and welcome. My name is Mark Stavely and I'm a program manager working on Azure's GPU program that includes GPU computation and high-end visualization. I'm here to talk to you about some of the great new things that we are bringing to Azure with regards to GPUs. As you can see here, this is an overview of the Azure ecosystem, and I'm going to be talking today specifically about some compute VMs, virtual machine types that we're bringing to Azure that involves GPUs for high-end visualization and compute workloads. Before I dive into the specifics, I want to talk about our vision and design. We want to integrate GPU capabilities into the Azure infrastructure so that we can have a competitive price and performance story that supports both compute for GPUs and high-end visualization. And we are super excited to be bringing this to market through a partnership with NVIDIA. Our core scenarios relate to cloud-based streaming and gaming, supporting high-end video processing and encoding workloads, as well as accelerated desktop applications using OpenGL and DirectX, and GPU compute workloads that span single and multiple machines. Our cloud architecture starts with applications at the user level, working through on top of a client OS, and we're bringing to you today news about our new GPU virtualization technologies that's built on top of our host operating system and hardware. If we extrapolate this out for what this means to you as the customer and partner, we're giving you a means to bring custom applications, your data applications and workloads from the Azure Marketplace, your own operating system images, and different types of Azure VMs. We're really excited because the virtualization that we're bringing and allowing with GPUs is done through Hyper-V using discrete device assignment, or DDA, that allows for the GPU to be passed through with minimal performance impact. This is built on top of our Azure core infrastructure and services, so all of your standard experiences will remain the same. We're really excited to be bringing the M60 GPU hardware for that Quadro high-end enterprise graphics needs, as well as the K80 GPU hardware, which is best of class for GPU compute. So we're announcing the N-Series virtual machine offerings on top of Azure. We have 5 offerings that we are planning to go to market with, and I'll be talking through a number of the different scenarios and cases why we have these virtual machines. So the first type of virtual machine that I would like to talk about is in our N-Series, relates to visualization capabilities. Here is a listing of the specifications for the N1 VM size. 6 cores on an E5 2690 V3 processor, 64 gigs of RAM, approximately half a terabyte of SSD connected into our standard Azure networking, and it will give you 1/2 of an M60 GPU card. As you can see here in this example, this is a screenshot of work we've been doing where we are showing DDA in action and exposing up the NVIDIA Tesla M60 GPU through DDA, thereby allowing it to our virtual machines as an infrastructure. I'd like to show you a demo we captured recently running an M60 through DDA and Hyper-V, components of SpecView Perf, and it's showing how we are truly able to bring these high-end type of engineering and rendering workloads to the cloud. We've been tremendously pleased with our partnership through NVIDIA and leading the way to bring Quadro graphics to the cloud. It's super exciting, and we know it will mean a great deal to our customers. This means that you will be able to run these types of workloads in any device because you have the power of Azure behind it. I'd like to introduce one of my colleagues, Chris Hybritz, who's a senior program manager with the GPU virtualization team. And Chris, I wanted to hear from you. What does it mean for you that we are bringing this kind of GPU capability to Azure?
Well, we're really excited, Mark. We've been in this space for GPU virtualization for a number of years, but this is the first time that we're able to go to our customers and say, hey, we're bringing this to the Azure platform itself. As you saw with some of those demos, some of these really high quality visualization applications require quite a lot of GPU performance. And with the DDA capabilities, the hardware pass-through of that actual GPU, we're able to leverage all the hard work that the application developers themselves, the optimizations that the device manufacturer as well as the device driver as well as the work that they've done with the device driver, to really shine. So these applications should run without any changes whatsoever, leveraging all that hard work and support that they've already put in. Since we've had a long history of being in the virtual GPU space, we also have a lot of relationships that we're able to leverage to help ensure that all these applications that we work on our existing platforms are able to leverage this new exciting platform for Azure.
I agree. I feel really excited about what we're going to be able to bring to our customers with this new functionality and hardware, and what you're saying about the DDA providing minimal hindrance on performance and compatibility. I think is pretty fantastic too.
Excellent. I agree 100%.
Very cool. Thank you for joining me today, Chris.
That's not a problem. Thanks, Mark.
Now we're going to move on to the next type of virtual machine that we'll be offering with our N series that highlights the need for, or deals with the need for, single machine GPU compute. You can see we have 3 different offerings, each with varying degree of compute cores and memory, up to 256 gigs of DDR4 RAM and up to 2 terabytes of SSD. We use the NVIDIA's K80 card as our building block, and we offer 1 K80 GPU, which is half a card, or a full card, which is 2 K80 GPUs, or 4, which is 2 cards. And we feel this is really exciting because it gives our users lots of flexibility in what size and scale of workloads they want to spin up from a compute point of view. Again, as I mentioned previously, with the M60, we're using DDA to deliver this GPU capability to our users so we can maximize performance and compatibility of applications. And here's an example of a screen capture that I did recently that shows the NVIDIA Tesla GPU being passed up through to a client OS running as a virtual machine on top of Hyper-V. We're super excited about this. This is leading edge stuff, and we are thrilled to be partnering with NVIDIA to drive this to our customers. With me, I have my guest. I have Dr. Misha Belenko, who's a principal research scientist with the Azure Machine Learning team. And so, Misha, when you heard this news about us bringing K80 GPUs as a virtual machine type to Azure, what does that mean for you? I can see the smile on your face already. I'd love to share some of your passion with our audience.
It means yay! So, in the recent years in machine learning, deep neural networks had been a really exciting area with really strong empirical results, as well as really interesting algorithmic developments. And the state of the art for neural networks right now is generally run on GPUs. They give pretty unique advantages for getting huge speedups. And for us, Azure ML and Cortana Analytics platform, this is great news because the mission for us is to bring advanced analytics capabilities to everyone, making it very easy to run advanced machine learning algorithms. So giving everyone the ability to run them on state-of-the-art hardware, such as the one we provide, will be great news for lots of our customers. I'm
really excited as well, given that the customer has so many options with leveraging this GPU hardware. Somebody could go and get a virtual machine and write their own CUDA program, or they're able to leverage, as you say, Azure ML and the Cortana Linux framework. I think that's super exciting as well, being able to give our customers the ability to use the services we offer, as well as bring their own research and bring their own development to the cloud.
Right, and that's where I think it'll be very important to give people a range of options, whether they want to roll their own, so to say, and use raw packages, such as open source packages that we'll be happy to integrate with, or they just want the solutions that we have ready for them as modules and just run them with a few clicks, and then operationalize them as services with a couple other clicks.
That's right. Yeah, thank you for sharing your excitement with me and our audience today. We're just really glad you could come and make the time and chat with us. So
thank you. Can't wait.
Thank you very much. I want to talk to you next about an additional offering we have with our N series. It's a way of providing multi-machine, multi-GPU capabilities. You can see with the N21 series, or N21 VM, we offer 24 cores on the E5 2690 V3, 256 gigs of DDR4 RAM, approximately 2 terabytes of SSD, and in addition to the standard Azure networking, we're offering a high-speed RDMA network that allows you to build out multi-machine GPU clusters. This is all based using the NVIDIA's K80 GPU, which gives us best-of-breed Tesla compute performance, which we're really excited about to be able to bring to our customers. With me today, I have Frank Zaida, inventor of the Skype translator, who's a principal researcher with Microsoft Research. Frank, I know that in a lot of your work that you do, you rely on these GPU farms and GPU clusters to advance state-of-the-art deep learning and deep machine learning technologies, driving an insight. Can you share with us some of your thoughts about hearing this news that we are bringing these kinds of capabilities to Azure?
Yes, this is brilliant. To give a bit of background, so Skype Translator is the system that allows people to make phone calls to people that speak a different language, right? And their speech is automatically translated, and part of that is speech recognition, right? And speech recognition uses machine learning. Specifically, we are using what's called deep artificial neural networks. And to create those networks, you basically need to give them a huge amount of samples and process those samples with those networks so they learn how to recognize those things. So to give you an idea, in our case, we are running through about 3 billion samples, and every single sample takes about 120 million multiply and accumulate operations.
Wow.
So in order to finish one of those training runs on a single GPU, we use GPUs for that, right? On a CPU, it would be hopeless. On a GPU, it would take several weeks to finish such a process. Yes. But thanks to the GPU farm that basically you and your colleagues built for us at that time when we did that, we were able to develop algorithms that parallelized this training process and then cut down the time down to something like a little bit less than 2 days.
Wow.
Now, why is that important? Because all of these machine learning, building a machine learning-based system normally means you're optimizing the system. So you do a lot of experiments. You make an experiment, see what works, what doesn't, tune some parameters, do it again. And the more cycles you can do, the better the final product will be.
Yes.
And by speeding this up by 10 times or something like that, we were really able to build a speech recognizer that was good enough for being put into this very difficult task of speech-to-speech translation.
Yes.
Without that, it would be completely impossible to get to that point.
Right. And to combine that now with the flexibility, the infrastructure that Azure brings, somebody could go and build one of these clusters at the click of a button.
That's right, and that's what we do. We don't run experiments all the time, right? At the moment, I'm doing something completely different. I'm writing code, but at some point, I suddenly have this requirement of, 100 GPUs or 200 GPUs, and this is what this would allow me to do. And that doesn't only apply to building a product like Skype Translator. So my main job is research, not really building a product. And in research, we do the same thing, running experimental cycles, and also there, it really sort of supercharges the kind of the speed in which we can run these experiments. Right. And that not only applies to speech recognition. There are other, in the general area of deep learning-based sort of artificial intelligence applications, including machine translation, language understanding, image recognition. There's a lot of stuff going on in that area, and all of those will benefit from the kind of parallelization on multiple GPUs or on many GPUs.
That's fantastic. Thank you for sharing your excitement with us today, Frank. We are super thrilled that we're going to be able to bring this to our customers.
Thank you very much.
My next guest, we're going to be talking about something really fantastic. It's a partnership between Microsoft Research and Azure, looking at something called Azure GPU Research Labs. I have with me Dr. Chris Basaglu, who's one of the principal development managers with the Azure GPU Research Labs. And so, Chris, hearing all this news about GPU capabilities coming to Azure and talking about or starting to introduce our partnership with Microsoft Research, I'd love to hear your thoughts on this and hear about what you'd like to share with our customers and partners.
Right. So in Microsoft Research, with partnership with Azure, we've built a specialized cluster and a service, especially for deep neural network training. We use this cluster now internally for all of our big data jobs inside of Microsoft. So, for example, training speech recognition models for Cortana or doing image recognition for search are all done using this new cluster and service. And I'm happy to announce that coming soon, this service will be made public through Azure GPU for external parties.
So we're really excited. I mean, the fact that this is the same technology and same service that you're using for training Cortana and your machine learning workloads is really fantastic. This collaboration between Azure and Microsoft Research is quite fantastic.
Right. One of the key things that this collaboration offers is the ability to harness hundreds of GPUs to build a single DNN training model. So training that used to take weeks can now be done in half a day. So you can generate 2 models every day and iterate the models as you go, get better and better.
So that's super fantastic. And from the Azure point of view, we are super excited for this partnership. And I really appreciate you being here with me today, Chris, and sharing in our good news about bringing the N-Series GPU announcement to the world, and also being able to talk about our joint Azure GPU Research Labs partnership.
Thanks, Mark.
Thank you, Chris. So wrapping up, I want to just review what we've gone over in this segment today. So our private preview for N-Series GPUs is coming in the next few months, and so we're excited to be working with partners and internal teams to be bringing this and making this available. Supporting those visualization and compute workloads is super important to us. We plan to support Windows and Linux operating systems for these N-Series virtual machines, and research partners will also have an opportunity to work with the Azure GPU Research Labs going forward. We are also really super thrilled about our partnership with NVIDIA and the great joint engineering work that we are doing with them. Thank you very much for joining us today. We are super excited about our N-Series offering.